An astounding disclosure made by the James Webb Telescope. City lights in space. Tracked down 7 trillion miles from Earth, this important finding has sparked interest in the chance of extraterrestrial life. The telescope focused on Proxima Centauri b, the closest exoplanet to Earth, uncovering strange splendid lights radiating from it. What could be the justification behind these city lights on Proxima Centauri b? Could this ever prove the presence of life on our planet? Join us as we dive into how the James Webb Telescope distinguished these exceptional objects in space. For a really long time, researchers and the public have speculated about life beyond our planetary local area. Any evidence suggesting life has been enthusiastically welcomed. Recently, the scientific community was stunned when solid proof of living things was seen by the James Webb Space Telescope while investigating space and detailing pivotal information back to Earth. The James Webb Space Telescope noticed particular city lights sparkling from the exoplanet Proxima Centauri b. These lights were, as its name suggested, lights resembling those illuminating a distant city. The probability of an alien city existing on the star has left researchers bewildered and stunned, as it seems like the existence they've all been waiting for. If this ends up being true, as everybody believes it will, it actually means that there are intelligent living creatures building civilizations new to what humans know in space. Exploring the city lights found 7 trillion miles from Earth, NASA engineers can't resist the urge to consider how long these lights have been present in space, hoping that humans will develop the vital technology to detect them. David Kipping, a cosmologist from Columbia University, describes the Proxima Centauri b exoplanet, where the city lights were found, as fascinating. He said such a great amount has changed since the star framework nearest to us, warming designs that aren't similar to planets. The run-of-the-mill rocky planets are known to ingest sunlight and emit infrared radiation. Not so for this exoplanet, as its infrared nature is altogether different from that of its host star named Proxima Centauri. This requires a good observational eye by the James Webb Space Telescope, JWST, and the telescope proved to be useful as the right instrument for the gig. The JWST can actually detect infrared frequencies. The specific power mark of Proxima b will assume a critical part in revealing the general ties of its environment, and that will be done thanks to the latest technology of infrared imaging capabilities advanced by the JWST. Scientists expect to use the telescope to unveil the environmental elements of this planet at atmospheric levels. They also expect to use the Webb telescope to assess the possibilities of residence on this exoplanet. The James Webb Telescope has an infrared awareness that is ready to explore what occurs on Proxima Centauri b's evening side. Getting the slightest light emissions in the vast darkness is generally a struggle for space telescopes, but not for the JWST, as it can pick out even the smallest light emissions from space. It's the ideal instrument to check if the reports about city lights on Proxima b's night side are true or not. Not every artificial enlightenment in the universe can be identified by the telescope, as long as it falls within a frequency band that is multiple times smaller than the star. Proxima Centauri b has an interesting relationship between its divine elements and surface connections. The day side of the exoplanet contains various solar chargers that harness the searing solar energy conferred by the star. Its spectra edge also reflects incoming light beams. Meanwhile, when Proxima b finishes its circle around its host star Proxima Centauri, it experiences day and nighttime periods like what we have on Earth, with the daytime getting high on solar-based heat and the nighttime experiencing coolness. The planet is known to have temperature variation regulated by its composition. For instance, if there's no atmosphere on Proxima b, the difference between its day and nighttime periods will be wide and far between, assuming there's no regulating effect of atmospheric gases and oceans. The level of temperature variety is a good topic for cosmologists to unwind a deeper understanding of Proxima's air creation. Having an unmatched infrared imaging capability, the JWST can effectively analyze the planet's thermal emissions to provide intelligent data about its environmental properties. Strangely, the orbit of the James Webb Telescope around the Earth lines up with Proxima B's orbital period, giving complete observations of its 24-hour cycles within 11.2 Earth days. Since it undoubtedly has an atmosphere, the ensuing step will be to evaluate its climatic science to determine if it can support life. Some good pointers in determining if there's life are the presence of gases like oxygen, water vapor, and methane. If these elements can be seen on the world, it means that it supports habitable circumstances. The process of accurately determining this requires researchers to be meticulous enough as they capture and analyze light beams that travel through the planet's atmosphere. This is a highly challenging task to undertake. Although the JWST has great capabilities for characterizing planetary atmospheres, it has a different primary goal. The telescope has been programmed to only investigate the variations in water vapor, carbon dioxide, and methane concentration. When it comes to detecting enhanced oxygen, which is a pivotal sign of something going on under the surface, the JWST is limited in this space. However, the telescope still has significant motivations to look for other elements on the world like ozone, which offers an accurate measure of importance in the atmosphere. It's also really important that the James Webb Space Telescope doesn't have absolute capabilities, and it can't peer at a few of the nearest habitable worlds to Earth, conducting a thorough atmospheric assessment. Cosmologists are now leaning towards ground-based observatories, like the Extremely Large Telescope, ELT. The ELT is a telescope that has been designed to start operating in 2028, and it's carefully positioned to look further into the atmospheric composition of distant exoplanets. It'll provide data on these planets that will offer comprehensive and clear insights into their level of habitability. NASA scientists and everyone are eagerly anticipating the deployment of future space telescopes like these. Up to that point, however, the James Webb Space Telescope remains a crucial tool in our quest to unveil the secrets of distant exoplanets. Even with its current limitations, the Webb Telescope has the potential to offer valuable insights that will change how we interpret exoplanetary exploration now and in the future. Scientists have a goal for future space telescopes, and that is to reduce the amount of bright light coming from a planet's host star so cosmologists can better see the lights reflected from a planet itself. They intend to do this by using internal shades or large external sun shades that are shaped like an umbrella, like using your hand to shut out rays of the sun to enable you to see an object more clearly. Reducing the intense brightness coming from the host star, future telescopes will be better positioned to focus on faint reflections of light coming from a distant exoplanet, allowing clear analysis of its atmosphere and likelihood of supporting life. Doing this comes with its own challenges, however. Researchers must differentiate gases produced from life and those from geological cycles, like volcanic activity.